Hello and welcome to this presentation. My name's Ivan Rich and I'm CEO of HemoGenix. What I'm going to focus on in this presentation is a significant change in the NetCord-FACT standards and alternative assays to the CFU assay that you might want to consider. So what is this significant change? This is Appendix 3 of the latest 5th edition of the NetCord-FACT standards. The major change in these standards is that instead of only allowing the CFU assay to be used as a test for growth, the standards now state that a CFU or other validated potency assay is allowed and can be performed at any time prior to release. This change went into effect on September 29, 2013. What this means for you is that it is not a requirement to perform a CFU assay. You can now use other assays that are available, providing you can validate them. I shall come to the validation parameters a little bit later in this presentation. But first, let's consider the CFU assay and alternatives that you can now use. The colony forming unit or CFU assay has been the only functional assay available for hematopoietic cells since the early 1970s. The products that you're probably most familiar with are those from stem cell technologies that require counting colonies in duplicate 35mm Petri dishes. In 1982 I miniaturized this assay and it is now called Cameo 4. It requires about 1/10 of the reagents and cells that you would presently use for your CFU assay, so there's an advantage there. However, as you may know, there are significant problems with the CFU assay. This table shows how we have solved these problems that are encountered with the conventional CFU assay. So first, the assay requires usually manual enumeration, which is highly subjective. Our assays are non-subjective because the readout is instrument-based. You also need a high degree of technical expertise required to perform the CFU assay, and there's a steep learning curve for identifying colony types. With our assays, accurate pipetting is the only expertise required, and the assay can be learned in just 2 days. Colony counting is not a standardized procedure, and even image analysis recognition software has problems. With our assays, and for many of our assays, the readout is calibrated and fully standardized prior to measuring the samples. One of the major problems with the CFU assay are the high coefficients of variation, or CVs, due to dispensing errors and colony counting. These are obviated in our assays by the fact that we use suspension expansion culture and bioluminomics technology that reduce these problems. The CFU assay cannot be validated due to a lack of standards and controls. All our HALO assays have been and can be validated according to FDA and EMA regulatory requirements. Another problem with the CFU assay is that it takes 12 to 14 days for the results to be obtained, because cells have to differentiate and mature to identify the colonies. This isn't the case with our assays because they are all based on cell proliferation, and they require only 5 days and can actually be increased to 7 days for increased sensitivity. Finally, the CFU assays are operator intensive, time consuming and expensive to perform. With the assays that I'm going to be discussing today, you can process part or a full 96 well plate for results that take only 30 minutes to obtain. Assays can be fully automated and have a high throughput capability, and they are extremely cost effective. Because of the change in standards, you now have the flexibility to choose between luminescence, fluorescence, or absorbance assays, depending on the plate reader you have available in your lab, and assays for specific applications. The instrument-based assays that are directly equivalent to the CFU assay are Halo 96 PCAEQ, HemoFluor 96 PCAEQ, and HemoLite 96 PCAEQ. They use exactly the same growth factor cocktails as your MethoCult reagent. I'll come to this in a moment. I shall also be explaining the other assays shown on this slide, notably STEM-Predict, Halo 96 SPC-QC and PQR, and the PMT assays. But first, let's explore the difference between the assay readouts or signal detection systems used to measure hematopoietic stem and progenitor cells. Now, colony counting is a manual readout. All of the CFU-equivalent and alternative assays are instrument-based, and that is what you should strive for to achieve in for a clinical or patient application. Most laboratories have a plate reader. This is usually used for ELISAs. The plate reader may be multifunctional, in which case it might be possible to measure absorbance, fluorescence, and bioluminescence using the same instrument. If it is a dedicated instrument, it will only be possible to use one of the particular readouts. So in this table you see the different properties for the absorbance, fluorescence, and bioluminescence assays. The absorbance assays rely on the reduction of a tetrazolium substrate to produce a soluble yellow formosome product. The fluorescence assays use a coumarin-derived coumarin derivative that is cleaved by proteases in living cells. And finally, bioluminescence assays rely on the production or change in intracellular ATP concentrations by living cells, and this is detected by a luciferin-luciferase reaction. All of these assays are viability assays. In fact, they're all metabolic viability assays, but they can also measure proliferation or cytotoxicity. All of the assays use a single one-time addition reagent step. For the absorbance assays, the absorbance is measured using a 490 nanometer filter with the plate reader. For fluorescence, you need a 380 to 400 nanometer excitation filter and a 505 nanometer emission filter. But for bioluminescence assays, you don't need any filters. The absorbance assays require 1 to 4 hours for the reaction to be processed, or for the color to come to fruition. Usually 3 hours is an optimal time. For fluorescence assays, the reaction proceeds between 30 minutes and 3 hours. For bioluminescence, you only need 10 minutes. Absorbance assays are the least sensitive, but the bioluminescence assays are the most sensitive of all. Now, with respect to standardization and validation, absorbance and fluorescence assays are rather difficult to standardize because of the it's rather difficult to establish the standards and controls. However, all of the bioluminescence assays can be calibrated, standardized, and validated because they include the standards and controls within the assay. And finally, absorbance assays are a bit difficult to multiplex with other assay readouts, but the fluorescence assays can be very easily multiplexed with flow cytometry and bioluminescence assays. And the bioluminescence assays by themselves can be multiplexed with virtually any assay readout. Now, Common to all of these assays is the fact that none of them use or incorporate methyl cellulose. This drastically reduces error and variability. All assays incorporate suspension expansion culture technology for cell culture. This allows normal pipettes to be used, increases assay sensitivity, and reduces cell incubation times. With the exception of StemPredict, which is completed in just 3 days, all other assays can be completed in 5, 6, or 7 days depending on the required sensitivity and work schedule. All assays contain everything needed to culture and measure hematopoietic stem and progenitor cell proliferation. Now, one of the most important differences between the conventional CFU assay and most of our assays is that we focus on characterizing the stem cells. In the cord blood community, the term HPC, or more recently HPC cord blood, is used. HPC designates hematopoietic progenitor cell, but it is not the progenitor cells that are important. Only the stem cells have the property of engrafting and reconstituting the patient. It is the stem cells that have to be characterized to ensure a high quality and potent product for transplantation. And for this reason, our assays are used to help you characterize the stem cells in the product. So let's take a look at the CFU-equivalent assays. These are represented by HemoLite 96 PCAEQ, HemoFlor 96 PCAEQ, and Halo 96 PCAEQ. All are instrument-based CFU-equivalent assays. The assays are meant to replace the CFU assay, and they can be used for cord blood, mobilized peripheral blood, and bone marrow, or purify populations from these tissues. No methyl cellulose is used in the assays, so no colony counting is required. They come with exactly the same growth factor cocktails as the MethoCult reagents and include everything you need to perform the assay. As I said, exactly the same growth factors that are used in your MethoCult reagent, we've incorporated into our own CFU assay, the Cameo 4, and all of the PCAEQ assays for which you see the catalog numbers here. These assays allow you to convert from the CFU to an instrument-based assay. You can omit this step completely if you want to, or you can use it as a stepping stone for the more advanced application-specific assays that I'll come to in a moment. If you were to perform a CFU and PCAEQ assay side by side, this is the sort of data that you would probably obtain. Here you see the relationship between total colonies counted on day 14 using the CFU assay and ATP measured on day 5 using, in this particular case, Halo 96 PCAEQ, both as a function of plated cell dose. This shows a direct correlation between the three parameters. What this means is that for any cell dose you can calculate the ATP concentration, which is equivalent to the proliferation ability of the cells, directly from the total number of colonies counted. And this means that you can replace your CFU assay with a Halo assay or other PCAEQ assay. Let's now move on to the first CFU-Alternative an application-specific assay. This is StemPredict. It was originally developed to predict cord blood bankability. In other words, it provides you with the information that allows you to move a cord blood unit from temporary storage to permanent storage. However, it can also be used to optimize the collection of mobilized peripheral blood. StemPredict is a special Halo assay. It's completed in just 3 days, and it incorporates SEC and bioluminomics technology that allows for full calibration, standardization, and validation of the assay. It measures the ratio between hematopoietic stem cell stimulation and a background control, and this ratio must be equal to or greater than 1.5 to predict cord blood bankability and the mobilization of hematopoietic stem cells. The assay has high throughput capability using either 96 or 384 well plate formats, and is the only assay that can do this at the present time. So it allows large numbers of cord blood units to be sampled in one go. Here you see how to predict cord blood bankability. The upper graph shows the ATP concentrations for cord blood stem cells and their respective control on days 2, 3, and 4 of incubation. The lower graph shows the ratio of the stimulated stem cells to the control. This ratio must be 1.5 or greater to predict that the stem cells in the unit will exhibit sufficient viability and growth to warrant permanently banking the cord blood unit. The next application-specific assay is Halo96 SPC-QC. This is a stem cell quality control assay. Stem cell quality is the measure of stem cell proliferation ability at a specific time point and cell concentration. The assay measures 1 or 2 stem cell populations. These are primitive hematopoietic stem cells, or CFC-GEMM alone, or both the CFC-GEMM and primitive lymphohematopoietic stem cell, which we designate as the HPPSP. It's used to assess whether a procedure produces consistent results and or whether it produces a stable product. It too incorporates SEC and bioluminomics technology so that the assay is fully calibrated, standardized, and validated. Results can be obtained in 5, 6, or 7 days depending on the work schedule and the sensitivity of the assay required. This graph shows the variation in stem cell quality for 28 different cord blood samples frozen at different time points. The blue columns represent the primitive hematopoietic stem cells, while the red columns represent the primitive lymphohematopoietic stem cells. When stem cells in a cord blood unit produce ATP concentrations greater than 0.04 micromolar, they can be considered to exhibit sufficient quality to sustain proliferation. Cord blood units that show ATP levels below 0.04 micromolar should not be used because the stem cells will not sustain the necessary proliferation ability. In this way, you can compare the quality of the stem cells before and after a procedure, and if necessary, change the procedure in order to improve stem cell quality. At the present time, the CFU assay, specifically the granulocyte macrophage progenitor cell assay, is used to monitor time to neutrophil engraftment. In many instances, neutrophil engraftment occurs before the results of a CFU assay can be obtained, so why use a retrospective assay? This is one of the reasons why the CFU assay is not routinely used for bone marrow and mobilized peripheral blood. The alternative is to use a PMT assay. PMT stands for Patient Monitoring After Transplantation, and these assays are used to predict and monitor time to engraftment for granulocytes, macrophages, erythrocytes, and platelets by measuring the proliferation ability of GM-CFC, BFUE, and or MK-CFC respectively. Also used to monitor they're also used to monitor hematopoietic and or immune reconstitution by measuring 4, 5, or 7 different stem and progenitor cell populations simultaneously. They can be used for cord blood, mobilized peripheral blood, or bone marrow transplantation. They're available with absorbance, fluorescence, or bioluminescence readouts. And the PMT assays are more rapid than any CFU assay because they can be completed in just 5 days, or this time can be extended to 7 days. This graph shows the values of normal cord blood and bone marrow for 7 different cell populations. If values for BFUE, GM-CFC, or MK-CFC provide low values or do not increase, the assumption would be that engraftment is either not optimal or has not properly taken place. If there is no increase in stem cell or lymphopoietic cell proliferation, there must be a problem with the reconstitution process. PMT assays provide a far better ability to predict engraftment and reconstitution. The last assay I'm going to be describing is Halo96PQR. This is a potency assay. Within the stem cell therapy field, and especially in the cord blood community, measurement of potency is probably one of the most misunderstood parameters. Yet, it is also one of the most important parameters. There is only one potency assay available that is compliant with both FDA and EMA guidelines and regulations on potency, and that is Halo96PQR. This table shows the FDA regulatory requirements for a potency assay. As you see, a potency assay must demonstrate quantitative biological activity specific to the product, and the assay results must allow for release of the product. This means that the assay must predefine acceptance/rejection criteria for release of the product for use. A potency assay is not a potency assay if a reference standard of the same material is not included. In addition, standards and controls are required because without them, assay validation cannot take place. Finally, the potency assay must measure the identity and biological activity of the active components, and the active components in this case are the stem cells, because they are the only cells responsible for engraftment. Based on these criteria, the CFU assay cannot be a potency assay. Furthermore, total nucleated cell count, viability, and CD34 are not or cannot be potency assays. And that is why Halo96PQR was developed. Halo96PQR is a reference standard-based potency and quality assay that provides release criteria prior to transplantation. Use of the Halo96PRS assay prior to the PQR assay allows in-house establishment of primary, secondary, and tertiary reference standards for cord blood, mobilized peripheral blood, or bone marrow. The assay measures the quantitative biological activity of a minimum of 2 active stem cell component populations. Like all Halo assays, it incorporates SEC and bioluminomics technology so that the assay is fully calibrated, standardized, and validated, and results can be obtained in 5, 6, or 7 days. I'm not going to say too much more about cord blood potency, only that on the HemoGenix YouTube channel there is a series of 4 presentations that discusses potency in detail and how it is measured. But let's take a quick look at some results. Cord blood potency cannot be measured by performing a simple CFU assay. Potency should not be performed prior to cryopreservation, because the potency of the stem cells is going to change as a result of the freeze-thaw process. Potency measurement is a more complex assay and should be performed once a cord blood unit has been chosen for a patient. First, an in-house cord blood reference standard has to be established. Second, the stem cell potency ratio for at least 2 stem cell populations has to be determined by comparison with the reference standard. Third, from the cell dose response curve for a cord blood sample, which you see here in the left-hand graphs, the stem cell quality at a specific cell density has to be determined and must be greater than specified acceptance limits. This is shown in the upper right-hand graph. Finally, the cumulative potency ratio for both stem cell populations, which is shown in the bottom right-hand graph, must be greater than that for the reference standard. Only then can the sample be released for transplantation into a patient, because only then has it been shown that both stem cell potency and quality are sufficient to predict engraftment. Now you might ask, why do PCAEQ and PMT assays include absorbance and fluorescence readouts as well as bioluminescence readouts, while STEM Predict, Halo 96 SPC-QC and Halo 96 PQR are only available in bioluminescence readouts? The answer to this question is that for STEM Predict, Halo SPC-QC and PQR, you need to be able to compare your results either over time, before and after a procedure, or with a reference standard. In addition, to detect and measure changes in stem cell biological activity, which these assays do, you need the most sensitive signal detection system available, and only bioluminescence can provide that sensitivity. There is also an absolute requirement for the assays to be calibrated and standardized for these particular procedures. This can only occur if standards and controls are available. These standards and controls are always included and should always be performed with any Halo assay. In addition, if you are applying for a biologics license from the FDA, then you will need to validate the assay, or at least show documentation of validation. Validation can only be performed if standards and controls are part of the assay. Here you see a typical ATP standard curve and controls. The assay parameters that you would look for when using a Halo assay prior to measuring a sample are also shown here. If these parameters are within specific ranges that are provided in the assay manual, you know that the assay will have been calibrated and standardized, and everything is working correctly for you to measure your samples. These are the validation parameters for the Halo assay. Obtaining similar results with a conventional CFU assay would be impossible. In fact, the validation parameter results you see here are compliant with an FDA-validated bioanalytical assay method for GLP. What this means for you is that when you use a validated assay, you can trust the results from that assay. In addition, our Halo 96 PQR and SPC-QC assays have FDA master file numbers. That means that if and when you apply for an FDA biologics license for cord blood and need to provide documentation for the validated assay, you can contact us to reference the FDA master file numbers. The FDA will then access our master file, and all of the validation documentation will be available to them. If you need to validate the assay in your own lab, contact us. We can help you. So in summary, with changes in NetCord-FACT standards, you now have the flexibility to use the assays you consider the best that will provide you with the cell characteristics necessary for the product. To replace the conventional CFU assay and verify the results between the CFU and instrument-based assays, the PCAEQ assays are available to you. To predict cord blood bankability or optimize mobilized peripheral blood collections, STEM Predict is the assay to use. To ensure cell processing and other cell methodologies are optimized to maintain stem cell quality, use Halo 96 SPC-QC. To predict engraftment ability, or time to engraftment, and reconstitution, the PMT assays are available. And to measure stem cell potency and quality to predict engraftment potential and define the release criteria, the Halo 96 PQR is the assay of choice. It is the characterization of the stem cells that is the most important aspect of providing a high quality and potent product for those people who are relying on you to provide them with a life-giving therapy. Regardless of whether you use an absorbance, fluorescence, or bioluminescence assay, You will always be using a far superior, easier and more rapid technology than any CFU assay can offer to help provide that characterization. And to help you further, we include everything you need to perform the assay. You just need to focus on providing the cell sample. We've done the rest for you. And anytime you need help, whether it is for technical advice or helping to understand the results that you've obtained with the assay, contact us directly, even if you've purchased the product through a distributor. We're here to help you. We will get back to you as soon as we can. So this webinar or this presentation was given prior to the AABB meeting, and if you attended that meeting, then I hope you visited our booth in Denver, Colorado. So I'd like to thank you for taking part in this presentation, and if you have any questions, please email us or give us a call. We're here to help you. I hope it's been of interest and help to you. Bye-bye.